A new robot known as the Mini Rover has developed and tested complex locomotion techniques robust enough to help it climb hills covered with granular material and avoid the risk of getting stuck on some remote planet or moon. The rolling hills of Mars or the moon are a long way from the nearest tow truck. That is why the next generation of exploration rovers will need to be good at climbing hills covered with loose material and avoiding entrapment on soft granular surfaces. This mini rover is built with wheeled appendages that can be lifted and wheels able to wiggle. Using a complex move, the researchers dubbed rear rotator pedaling, the robot can climb a slope by using its unique design to combine paddling, walking, and wheel spinning motions. The rover's behaviors were modeled using a branch of physics known as pterodynamics. This rover has enough degrees of freedom that it can get out of jams pretty effectively. By avalanching materials from the front wheels, it creates a localized fluid hill for the back wheels that is not as steep as the real slope. The rover is always self-generating and self-organizing a good hill for itself. The research was reported in the journal Science Robotics. RP-15 was a robot built by NASA's Johnson Space Center. That robot pioneered the ability to spin its wheels, sweep the surface with those wheels, and lift each of its wheeled appendages where necessary, creating a broad range of potential motions. Using in-house 3D printers, the Georgia Tech researchers collaborated with the Johnson Space Center to recreate those capabilities in a scaled-down vehicle with 4 wheeled appendages driven by 12 different motors. The rover was developed with a modular mechatronic architecture, commercially available components, and a minimal number of parts. The rover's broad range of movements gave the research team an opportunity to test many variations that were studied using granular drag force measurements and modified resistive force theory. The researchers also tested their experimental gates on slopes designed to simulate planetary and lunar hills using a fluidized bed system known as scatter, systematic creation of arbitrary terrain and testing of exploratory robots that could be tilted to evaluate the role of controlling the granular substrate. In the paper, the authors describe a gate that allowed the rover to climb a steep slope with the front wheels steering up the granular material, poppy seeds for the lab testing, and pushing them back toward the rear wheels. The rear wheels wiggled from side to side, lifting and spinning to create a motion that resembles paddling in water. The material pushed to the back wheels effectively changed the slope the rear wheels had to climb, allowing the rover to make steady progress up a hill that might have stopped a simple-wheeled robot. Simple motions had proved problematic for Mars rovers, which got stuck in granular materials. The gate discovered by this research team might be able to help future rovers avoid that fate. Though the mini rover was designed to study lunar and planetary exploration, the lessons learned could also be applied to terrestrial locomotion.